Okay, titration calculations. Usually we're either given a question like this, or we've actually been through and carried out the titration to get those values. What we're going to do today is we're going to look at how we actually solve these calculations in terms of the information that's given. So the first thing we need to do is to extract the information we're given. So what we're given is we're given a concentration of our sulfuric acid, and that's 0.1039 moles per litre. We're given a volume of our sulfuric acid, that is our aliquot, so that is 20 mils, and we can calculate the volume of the sodium hydroxide, which is our average of our three concordant titers. Now please note that titer there is not a concordant titer, so we just do the average of that one, and that one, and that will give us an average of 16.5 mils. Right, given that information, we can determine the concentration of the sodium hydroxide solution by going through and using this equation and doing some calculations. The first step we need to do is we need to calculate the number of moles of sulfuric acid. The reason we do this is because we know the concentration and the volume, so the number of moles is the concentration times the volume, which equals 0.1039 multiplied by, now the volume has to be in litres, so all we do is we make that by 10 to the minus 3, which will give us a result of 2.078 by 10 to the minus 3. That's told us how many moles of sulfuric acid are in the 20 ml aliquots. Each of those aliquots has reacted with the sodium hydroxide in the solution, and if you notice, there is a 1 to 2 molar ratio of the sulfuric acid to the sodium hydroxide, so we can say that the number of moles of sodium hydroxide equals twice the number of moles of the sulfuric, which equals 4.156 by 10 to the minus 3. We also have a volume of our sodium hydroxide, so we can calculate the concentration of our sodium hydroxide by just slipping it into the number of moles over the volume, which equals 4.156 by 10 to the minus 3 divided by our volume. Again, we've got to convert that to litres, so 16.5 by 10 to the minus 3, and that will give us 0.252 moles per litre.